Good afternoon, sir.
Good afternoon. How are you?
Good, sir. How are you, sir?
Almost fine. Last week was little. Actually, my wife was not well. These days, some another type of viral is coming now.
Yes.
Continuously 5 days she used to have this fever, 102, 103, like that.
How is she now, sir?
Now she is fine. Now she has almost recovered. So only weakness, little bit of weakness is there. Otherwise, no, no cough and cold, no fever, all gone. So it's good now, no problem.
Yes, sir.
Okay,
Good
so
afternoon, sir.
good afternoon, Jiti. Okay, how are you? I'll share the screen.
Yes, sir, sure.
Just one. So I hope everything is going fine in school and your preparation,
Yes, sir.
because we are now halfway almost. So
Yes, sir. From
after this,
October 3rd, we are having midterms.
midterm October, right?
Yes, sir.
Okay, good. So midterm, I think Pragya told me till three chapters, like first, second, and third chapter will come in midterm.
Yes, sir, only three chapters.
No, only four chapters are there, and four chapter is little, only little portion. Three chapter means 90% covered. So, electricity. This chapter is done,
Almost.
almost done. Okay, good.
Sir, the laws of Joule's law of heating is done.
Okay, okay. Joule's life heating means only power is left, and so power of the power generally
Sir,
that. Yes,
sir,
yes.
can you please teach electricity chapter like from starting, sir?
I'll start now. First 15 minutes I'll give you a brief idea about this chapter. Then we'll start with your questions. Okay.
Yes, sir.
1 minute. I think someone is there. Rajat. Okay. So this chapter is all about charge. Okay. Whatever physical phenomena is related with charge, that we study in electricity. So electricity means related to charge, just like gravity is related to mass. In same way, electricity is related to charge. So whatever phenomena we have related to charge, that we are studying electricity. Now this charge, we'll discuss a little about this charge also, but first we'll divide this electricity chapter into two parts. First part is called electrostat. Okay, electrostat means the charge is stable. Is this those phenomena which are related to a stable charge, a stationary charge. So that we are studying electrostat, a stationary charge, and few because only two possibility, either the charge is stationary or it will be moving. So moving charge generally we call it current electricity. So broadly we can divide this chapter into two parts, electrostatic and current electricity. Only two parts are there. Here in 10th grade, most of the topics are related to this, because moving charge, it's related to moving charge. Okay. So those phenomena which are related to moving charge is called current electricity. So now we'll discuss about the topic. So in electrostatic, actually we start with a stable charge. So charge will have some, suppose there is positive charge. Okay, suppose here we have one positive charge which is stable, positive or negative. Two type of charges we have. So any kind of charge. So now suppose this is positive charge. So electric field be because Just like mass, if suppose mass is there, suppose earth, so surrounding earth there is gravitational pull, right? Gravitational field we call it. Because of that gravitational field we will feel gravitational force. In the same way here, if there is charge, then there will be a field surrounding this area. Field means the area, some area it will cover. So this is called as electrostatic field. So electrostatic field, first we study about field. This is not there in the syllabus, this will come in 12th grade. So electrostatic field and force, electrostatic force, these two topics are not there, but these are the basics of electrostatic. Then we have electric potential, that is given in your syllabus, it is given in your book. So first topic for 10th grade is electrostatic or electric potential, and second is potential difference. Second topic is potential difference, electric potential difference. Very slight difference is there in between these two terms, electric potential difference. So only these two topics are there in electrostatic. Rest all like related to field, force, capacitor, nothing is there in this 10th grade. In 12th grade it will be in detail. So only two topics, we have to understand this potential and potential difference and formula, and based on that formula we have to solve some numerical. One formula we have, V equal to W by Q. This is the general formula for potential and potential difference both. But there is difference between these two terms, okay, that we will discuss, wait. So electricity is related to charge. Charge can be either stationary or moving. So stationary charge, these terms are related. Okay, now current electricity. So first topic in current electricity is electric current itself. Electric current. Current means which is flowing. So electric current. In electric current, because if there is current, it will flow into something, so that it needs some circuit. So that's why we have to study about electric circuit. Without electric circuit, it will not flow. So that's why it needs some circuit in which the current will flow. So potential and electric current, and then circuit. Then we have relation between potential and current. That relation is called Ohm's law. Ohm's law is nothing but the relation between potential and current. Current, suppose you represent current by I, so V is directly proportional to I. This is Ohm's law. This is very important law. Based on this we have many applications. So Ohm's law. Ohm's law, we get one new term in Ohm's law, that is called resistance. V equal to Ri we represent generally. If you remove this proportionality sign, it will come equal sign, and R will come. R is a constant which is called resistance. So resistance, new term we got resistance. So after Ohm's law we have to study about resistance and resistivity. So there is little difference in between these two terms also, resistivity. Okay. Then if we will come, wait. So resistivity. After this, related to resistance itself, we have two things. First, combination of resistance. Two formula to find the resistance. First, from this formula, Ohm's law, we can find the resistance. Second, another formula we have, resistance equal to rho L by A, cross sectional area or thickness we can represent. So combination of resistance. Now combination of resistance, we have to study two type of resistance. We have two type of combinations, parallel and series. So these two combinations we have to study, parallel and series. After this we have heating effect, because current has some effect. It does not have only field, because electromagnetic means magnetic field is also because of this current. So if current is, charge is moving, two things are there. First, electric field will be there, and apart from that, magnetic field also be there. So that is next chapter. After this we have magnetic effect of electric current. The name of the chapter is magnetic effect. But one another effect, that is heating effect, that is there in this chapter. Heating effect of electric current. Heating effect of electric current. So two effects we have to study. One heating effect and second this magnetic effect.
Magnetic effect.
Magnetic effect we'll study next chapter, but only introductory part is there, not much. I think almost 60% of the portion is removed from the syllabus. So only introductory part we have to study about this magnetic effect of electric current. So this much is there related to current. Now one by one we will discuss. So this much portion means this much content is there in your syllabus. So first, because one question definitely will come from this side, because electrostat they have to touch in exam, because only two parts are there in electricity. So one question will definitely come from this side. Either they will ask what is electric potential, or they will ask what is electric potential difference, or they will ask one numerical related to this formula. Okay. So you have idea what, because I think in NCERT book this means clear definition is not given, means they have not differentiated these two terms, electric potential and electric potential difference. So little difference is there, that we will study. Wait. So you have idea about this potential and potential difference? Anyone? First we will discuss about electric potential. What is electric potential and why we call it electric potential? What is the meaning of potential?
The capacity.
Yes, capacity or the stored energy, right? Generally
Yes.
potential energy, right? You have heard this potential energy and kinetic
Yes,
energy.
sir.
So kinetic energy means the energy due to motion of an object, and this is potential energy is energy due to position of an object, change in position. So change in position means it has the stored energy. Potential means a stored energy. So now with the help of this concept we will explain this electric potential. So electric potential is about 1 point. First thing, it's about 1 point, and potential difference is about 2 points, because difference term is there. So 1 point first. 1 point, any point, suppose P, in an electric field. So there should be an electric field, but this concept of electric field is not given in your book. But suppose there is positive charge, so there will be field surrounding this positive charge. Suppose 10 coulomb charge is there. What is the unit of charge? Coulomb. So now there is a field surrounding this, and this field we represent with the help of these lines, outward field. In case of positive charge, outward field will be there, and in case of negative, inward. So this arrow will be in this direction, inward. So suppose this is one charge. So any point we take, suppose this point P we are taking. So we have to find the potential of this point due to this charge. Okay, that is the concept behind this electric potential. Potential means it's about a point in an electric field. So how we define that point? Because it has some energy, that's why it's a stored energy. Why it has some stored energy? That one example I'll give. Wait. So suppose you place one, this is 10 coulomb, 2 coulomb charge you place here, positive charge. Then what will happen? If 2 coulomb charge you place it here, suppose 2 coulomb charge positive you place here, then what will happen? If you remove, just place it, then it will start, because repulsion will be there, same charge repel each other. So this will start moving towards this direction, away from this charge. It means it has some energy, that's why it's moving. Without energy nothing will happen. So for work or to move something we require energy. So if you put some positive charge here, it will automatically move it this way. If suppose negative charge, then it will automatically move this way. So this movement is happening, this acceleration is happening because of some force which is applied with this charge, but there is some energy in this charge, that is why it is moving. So force and energy are connected, right. In 9th grade we have discussed acceleration is related to force, force is related to work, and work is related to energy, right. Wherever there is acceleration there will be force, or there is, if there is a force there will be acceleration. If there is force and object is moving, then there will be work done, and if there is work done there will be energy. So these are connected terms. Same thing will apply here. So now one positive charge, because this point with P will take, you take one charge, any charge, this charge, suppose Q charge you take here, positive charge, and this is called test charge, because we are using this as a test charge. Now you will start moving this from very far object. So we very far place, that far place we can assume as infinity, just like in light. If distance is very far, then we will call it infinity. So one object, positive charge is coming from very far, and you bring it to point P. Okay. So you have to do some work here, because these positive charge will repel each other. So you have to go against this repulsive force, correct. So against this repulsive force you are going, it means you have to do some work, and that work will be stored in this charge. So this charge is now at this place P, Q. So it was at infinity, now it is at P. So it has to travel this much distance, and you have to do some work. Your work will be stored in this charge. So whatever work is, wait, I think someone is there, wait 1 minute. No. Okay. One minute, wait 1 minute. So what we are discussing? Okay, so this one, okay, this positive charge. So you have to go against this force. So what will happen? You have to do some work, and that work will be stored in this charge. One similar condition I think you have done in the gravity chapter. Gravity chapter last year in 9th grade. So suppose potential energy, how you define? Suppose one object is placed on the floor. Now you start, if you increase the height of this object, then which one will have more potential, A position or B position? Difference
Sir, B.
B. Why? Because we have formula, potential energy equal to potential energy will increase with the height, and that we have formula. What formula we have? mgh, right? So potential is directly proportional to this position h. So if you, why energy of this object is increased? Because you did some work on this, so you lost some energy, that because you are moving this object to this position. So you are doing some work, and your work means your energy will go somewhere, because conservation of energy is always followed. There is no exception for the conservation of energy. So your energy will go somewhere. So your energy will be stored in this object. That's why we call it potential energy. So its potential energy will increase. It will be stored. Okay, it will be stored in this object. Same principle, because here also we are going against the gravity. Gravity is always in downward direction, and you are going in upward direction. It means you are going against the attractive force in this case. So, against the force actually you can say. So, you are going against the force. So, that is why your energy will be stored in this object. Same principle you can apply here. So, here also we are going just like gravity. Here you look, you are going against the force. Force is in this direction. Force due to this, these two charges will experience a repulsive force, but it is going against this force. So, your energy will be stored here, and this work, suppose work and energy are same, the units are same. So, this energy is in terms of work. So, work done, that is why the definition is given, I think like this. Definition for electric potential is work done in bringing a unit charge from infinity to a point P. So, potential, electric potential of a particular point, electric potential of a point, electric potential at point P, because electric potential at because potential is related to only one point, I have already said this. So, electric potential at point P is nothing but the work done in bringing a unit charge. Unit charge means we have to divide. So, V equal to, we have to write W means work done divided by charge. So, in bringing a unit charge from infinity to a particular point P. So, with the help of this formula we can define potential, electric potential. So, electric potential is nothing but it is a work done in bringing a unit charge from from infinity to a particular point P. So, this will be the potential of point P. So, this formula is a specific formula. This is not given in a 10th board this NCERT book, but in 12th grade you can see this. So, this is the definition of electric potential. Okay. Electric potential means work done, it is nothing but work done in bringing a unit charge from infinity to a particular point P. Okay. Now, you got the idea about this or confusion?
Yes, sir.
So, it is nothing
Yes,
but
sir.
work done, because it is related to potential energy. Potential also I explained, because your energy will be stored, that is why we call it potential. So, it is work done per unit charge, because we have to take unit, either you take 1 coulomb charge here or any charge, test charge can be anything, any charge, that is why we call it test charge. So, test charge can be any, suppose 2 coulomb, 5 coulomb, any coulomb, and so any charge you can take, even smaller, 10 millicoulomb, microcoulomb, anything you can take at test charge, and you have to move this charge to this point P. So, you have to do some work, that work is nothing but the potential. If you move unit charge, then no problem, no need to divide by Q. So, that work done will be called potential. Otherwise, if suppose there is test charge, any arbitrary value for this charge, then we have to divide that charge, work done by divided by, so work done per unit charge. Okay. So, this is the definition. So, you can write, I will send one PDF, there I have written all this. So, directly there I told you 3 possible questions come from this side, electrostatic. First, definition of electric potential. Definition will be like this, electric potential is work done in bringing a unit charge from infinity to a particular point P. Okay. This much, with the help of this formula you can explain. Now, potential difference. Now, you understand potential, now potential difference. So, there is little difference between these two terms. Potential difference is nothing but, here one point we have taken as infinity. Now, in case of potential difference, electric potential and potential electric potential difference. Potential difference. So, in case of electric potential difference, we have to take, difference means what? At least 2 points we have to consider. So, here 2 points we have to consider. So, not only P. So, suppose in this field we will consider 2 points A and B. Okay. And now, the same definition and formula is almost same, at the place of infinity and P we will write A and B. Suppose you one test charge Q is there, and you move this charge from A to B. So you have to do some work, and this work is nothing but A to B. You are bringing the charge from A to B. So work done per unit charge. So here potential difference will be like this: work done bringing a unit charge from point A to B in an electric field is called potential difference. Okay, this much difference only. In this case, one infinity was there. In this case, no infinity from point A to B. Okay, so this is the difference, main difference. In case of potential difference, there will be 2 points. Here 1 point, here 2 point. If you remember this, you will be able to define this. 2 points will be there, and it's nothing but same thing. In both case, it's work done. In both case, it's work done. So that's why work done in bringing a unit charge from infinity to point P, that will be electric potential, and here work done in bringing a unit charge from point A to B is called potential difference. So here we will write a formula for this is V A B generally, because we have to show it as potential difference. So difference between these 2 points A B will be work done. So W from A to B, you are bringing this charge from A to B, so we have to do some work, divided by Q, because we have to take the unit charge. So divided by, so this is the PD, generally we call it PD, potential difference, and this is only potential, electric potential. So these two, with the help of these two formula, you can define electric potential and potential difference. And from this they can ask some, because we have the formula, so they can ask the questions also, numerical also. And electric potential, this is how we define the potential. And what is the few for example, suppose I think this you know, what is the source of constant potential difference? Constant potential. Battery, yes, battery or cell. So suppose in a circuit we apply some battery, so this will produce some potential difference, and because battery have the constant potential difference, it will be constant always. So it does not mean, suppose it's 3 volts, so it will remain 3 volt till all the energy is exhausted. So it will remain 3, so it's a constant. Some potential source of potential difference may have the variable this potential also. So there is difference between cell and potential. Cell is only one cell like this, positive and negative, positive and negative. In case of battery, if you combine so many cells, it will be called battery. Okay, so now this potential also, this battery will also create a potential difference. A potential difference means current will flow through it, and it always that we will discuss in next topic. So here suppose one we will discuss one question, numerical question. So we will apply this. So potential difference, suppose one battery is there, 3 volt battery, and with this 3 volt battery, suppose 5 coulomb charge is passing through this circuit in suppose in 10 seconds or something. So 5 coulomb charge is passing through this circuit. So how much work is done by this battery? Because work done is always by someone. Here in case of this, battery will do the work. So 5 coulomb charge is passing through this circuit. It will go like this and it will come like this. If you connect this series, means close the circuit, then current will start flowing through it. And suppose 5 coulomb charge pass through this battery. So how much work is done by the battery? So directly we can apply the formula. So from this formula, V is given, V equal to W by Q. We have this formula. So two things is given. Third, they are asking, work done they are asking. So work done directly we can find V into Q. So V is how much? 3 volt. Q is 5 volt. 5 coulomb. So here 15 joule. Energy, work, the unit of work is always joule. Joule is an unit of work as well as energy. So here 15 joule of work will be done by this battery to transfer 5 coulomb charge through this circuit. So, this type of question they will ask, because one numerical is also possible from this. So, 3 question is possible, either they will ask the definition of electric potential or electric potential difference or one numerical. So, 3 possibilities, and I am 100% sure one out of these 3 one they will ask, because some question from electrostatic they will ask. Now, any doubt? Electrostatic we are done, then we will start with current electricity. Okay. So, definition I will send the PDF there, from there you can directly write. So, you understood this or not? Potential and potential difference.
Sir, if the circuit is broken,
then current will not pass. Without circuit we cannot have current. So, here also one topic will include electric circuit. So, electric circuit is very important. Without electric circuit we cannot have the current flowing through it. So, circuit should be closed, then only current will pass through it, otherwise current will not pass through it.
sir, I did not understand potential difference in batteries.
Potential difference, because potential difference in all cases, suppose in battery what we have, battery also in case of battery, charge chemical energy is stored. Okay, here chemical energy is stored and slowly this chemical energy will convert into electrical energy. So, potential difference, it is related, battery is also related to potential difference. So, suppose in cell at one, this is called positive, this one is called negative, suppose. It means here electrons are stored and here protons are stored. Positive charge and negative charge stored. So, because battery is nothing but a stored energy inside the battery in form of chemicals. Slowly those chemicals will start reacting, and means, and because this is the difference between these 2 points, it is positive charge, it is negative charge. So, there is potential difference here and here. Suppose you want to bring a unit charge from this point to this point. So, there will be some potential here, and from infinity, actually from infinity to this point, another you bring the same test charge to this point. So, there will be some work, and but both work will be different, because work can be also positive and negative. So, here suppose positive work, here negative work, and you have to take the difference. So, we will get some work done. So, there in here also same thing, because even in battery same thing is happening. Inside there will be electric field, because electric field always, electric field concept is not given in your book, but wherever there is charge there will be electric field. So, suppose this is positive terminal, so electric field will be like this, it always originates from positive, it ends into negative. Similar, suppose you connect one wire with this battery, in this wire there will be an electric field. Because of that electric field, electrons start flowing. Without electric fields there will be no electric force. If there is no electric force, electron will not move, and if there is no movement of electron, there will not be any electric current. So, here this battery will create an electric field inside this wire. Okay, and this here, because of this electric field, the electrons will start moving. And these two are also, this is negative, this is positive, because of the difference of the, because only 2 type of charges we have. Positive, generally this is not like electron and proton, generally at one place there is more accumulated charge and another place less accumulated. So, there is more surplus of electron, means suppose there is excess of electron this side, then this will be negative terminal, less electron this side. So, like this, and positive, plus and negative and minus is in another term also, plus is also always considered as at higher potential and this one as lower potential. That is why we require potential difference, there should be some difference, higher and lower, then only current will pass through it. So, battery is also a device which will create a potential difference due to difference in charge. Here in case of this battery or cell, we have chemical energy. Okay, difference of
Yes,
the
sir.
charge, difference of charge. This this will come in detail in 12th grade. These terms they have not given in 10th, but directly they have given potential and potential difference. That's why a little confusion, because to define potential and potential difference we have to define electric field as well as force, but these two terms are, these two topics we don't have in 10th grade. So that's why, because it's very broad topic. In 12th grade, electrostat, content of electrostat is more than current electricity, but here in 10th grade, electrostat is very less, only introductory part, and that only potential difference, because they have to define without battery how can we consider, without battery how can we make one circuit. That's why they have defined potential. Okay. So now potential and potential difference we did. Now current electricity. Okay. So current electricity, in current electricity we have many topics. We start with electric current itself. So electric current, how you define? This is easy. Electric current, how you
The
define?
rate of flow of charges.
Rate of flow of charge, but that flow will be, means where? There should be something. So here in
From one point to another.
one point to another point. Look, two type of electric current we have. Generally current we can have, generally in this electrostatic chapter or electricity chapter, we are concerned with the electric current which is flowing through wire, right, conductors. But there are some in chemistry, I think you have done this, electrolysis process, right, one positive terminal, negative cathode anode. So here also if you connect this with battery, then current will flow through this, right. Suppose this is positive terminal, negative terminal. So current will pass through it. In between this is electrolyte. But we are not concerned with this. This type of electricity we will not study. We will study only the electricity which is electric current which is passing through the wire. Wire means metals, generally metals. Best conductor is silver, then copper, and then aluminum. So only these three we use extensively. Aluminum is very abundant, but silver is the best conductor. We don't use because it's very costly, it's rare, so it's not that much abundant. That's why we don't use silver. Copper generally we use. So copper have less resistance than aluminum. So maximum these three, means we don't use iron for circuit generally. So these three are enough. So if if copper, because copper is little more costly than aluminum, so that's why sometimes we don't use this copper also. So aluminum is most abundant on I think you know this metallurgy chapter in chemistry. Aluminum is the most abundant metal. So that's why we have aluminum, so much of aluminum in earth crust. So that's why we use this aluminum as most of the high tension wire are made up of this aluminum. Copper generally in if suppose in a domestic circuit we use this copper wire inside the house. Silver, very exception, very few cases. Suppose you are making iPhone, then in that case you can make the circuit with silver. Okay. So here we are concerned with the electric current which is flowing through wire, not through this electrolyte. Electrolyte means suppose sodium and chlorine ions are present here. So this is a kind of electrolyte in the water. So here also current will flow, but we are not concerned with this. We are concerned with this one. So inside the electric wire, which one is the carrier? Pragya is coming now. Which is the carrier? Carrier means carrier of this electric current. So inside any material we have plus and minus, positive and negative. Positive means protons and electrons, only these two charges are there inside the atom. So here we have uh, protons and electrons, suppose positive charge and electrons are negative charge revolving around the atom, because everything is made up of atom. So in case of wire or metal, only one possibility, only electron can flow. Why protons cannot flow?
Sir, metals are positive.
Metals are positive. No, metals are positive. No,
The positive electrons repel each other.
Positive. Suppose this is copper wire, and this is made up of atoms, small atoms, right? So in the atom, both are there. Protons and electrons both are possible. Both are there. So why protons are not moving? Only electrons are moving. That is my question.
Sir, protons are inside nucleus. Only electrons are outside.
So outside they are loosely bound in case of metals, right? Loosely bound. That's why they can move. There will be lattice. They can move. But protons will not move. What will happen if protons start moving? Because that is also possible. Here, suppose here in case of sodium and chlorine ion, both will start moving. This is negative terminal, so sodium will go here, chlorine will go here. So both sodium as well as chlorine will contribute in the movement of ions, means movement of charge. So current in electric current, here both are contributing, positive as well as negative charge. But here only electrons, flow of electron is contributing for the electric current. Flow of charge means here only electron is there which is moving, not protons. Why? What will happen if protons will start moving inside the wire?
Sir, atomic imbalance.
Atoms. Yes, actually, it will not remain solid. That is the answer, right? If your atoms will start moving, atoms and molecules are moving in only in case of fluid, right? In case of solid, these atoms are fixed. Solid gas, a state of motion. That was question from there. Okay, so that's why only possibility, only electron will transfer from one place to another, not protons. Otherwise, it will not be solid. It will become liquid, fluid. Okay, so electrons are there. It's a charge carrier. So electrons are moving inside the. If you connect with this battery, then electron will start moving with, because of electric field will be because I told you just now, if you connect the battery or cell with this wire, then what will happen? Inside there will be an electric field because of this battery, and because of that electric field, all electrons will start moving because they will feel one force. So wherever there is electric field, there will be force. If in an electric field you place one, suppose that this is positive charge and this is electric field. If you place one charge, any positive or negative, suppose negative charge, electron, they will start moving in this direction because they will feel one force, just like gravity. If you on earth, suppose you release one object, it will start moving in downward direction, not in upward direction. Why? Because gravity is always attractive force. So this object will start moving in downward direction. Same concept here. In case of electrostatic, electrons will start moving towards this positive charge. So same thing happen inside the wire also. Electron will start moving towards the positive terminal. Okay, so this is the flow of charge per unit time. Flow of charge or rate of flow of, generally you can use word rate of flow of charge, that is better. So rate means divided by time. Rate of flow of charge is called electric current. Through a cross section also you have to mention. Cross section means, suppose cross section, I think you know, this area is called cross section. This is a wire. You take one area, cross sectional area, and you stand here and you just watch how many electrons are passing through this area. So number of electrons which are passing, electron or charge which is passing through this area is called electric current in 1 second. So we have to define, because rate means 1 second. So in 1 second, how many charge is passing through that cross section area is called electric current. That is the complete definition of electric current. So flow of charge per unit time through a cross section area is called electric current. So three things: rate means time you have to mention, charge you have to mention, and cross sectional area you have to mention. Okay, cross section area. So this is the definition of electric current, and the formula we have I equal to Q by T, rate of flow of charge. Okay, so this is the second formula. Apart from this, one more formula you have. This is there in your book, but they have not given because I think numerical is there, but they have not given the concept. Wait 1 minute. So one more formula related to charge. So actually I should have started with this, but I just forgot. Charge, how many points you know about charge? First, two types of charge are there: positive and negative. Okay, positive and negative. Example of positive charge:
Proton.
protons. What else? Apart from proton, sodium ion, all this alkali,
Metal,
metals,
metal.
metals,
Metals.
sodium, calcium 2 plus, aluminium suppose you take, then it will be 3 plus, like this. Similarly here negative, electrons, and in case of
Non-metal.
non-metal, suppose
Chlorine.
minus, oxygen 2 minus,
2 minus.
like this. Okay, I think nitrogen
Yes, sir.
nitrogen also na 3 minus, NH3, yes, possible. So okay, so this first two type of charges we have. Second, now some properties about charge. And charge is nothing but physical quantity, which is responsible, which is produced due to imbalance of the electrons approach. Generally what happens, if you take one substance, inside that electrons and protons are equal, that is why those are neutral. Most of the things which are in nature are neutral in nature. Neutral means protons and electrons are equal. So if you combine, then you will get zero charge. But if you at some place we can develop positive and negative charge. How? By increasing and decreasing the number of electrons in that substance, and that can happen through three ways. There are three ways through which you can produce the charge. Not produce means you can develop the charge. First, through friction, but just by rubbing, just like comb and hair example. I think this in junior classes also you had. So if you take one plastic scale also and you rub in your hair, then what will happen? That scale will have positive charge or negative charge.
Negative
charge, yes, and the hair will get positive charge. So electrons will transfer from hair to the scale. So that's why a scale will become negatively charged. Similar way, suppose you take glass rod and silk. If you rub it, it will become glass rod will become this time positive. Glass rod will become positive and silk rod will become negative. So electron will transfer from glass to silk. So this is one example. First, plastic and fur or anything you can take, hair. So these are examples. Here it will become positive, this will become negatively charged. So this will become negative, this will become positive charge. So like this. So through friction also, through friction we can develop charge. Through induction also we can develop charge. Induction means without touching. Here we have to touch, we have to rub with each other. These two materials are in contact with each other. In case of induction, without touching also we can develop. Suppose this ball, any ball, suppose plastic ball or something, we have got suppose positive charge on this. If you bring this near to this another ball, then what will happen? All the electrons will come to this side. So negative charge will develop this side and positive charge will develop this side. and this happened without touching. So, this is called induction. Third method, conduction. Through conduction also we can develop charge. Conduction means suppose at one place, now suppose you attach one ball is positively charged, another ball is negatively charged. Negative means more electrons are here, more protons are here. If you connect with this wire, it is a conductor, so if you connect with this wire, then what will happen? All the positive charge will start flowing to this side and electron will start flowing to this side. So, flow of charge will happen and they will balance each other. Okay. So, both charge, suppose here more positive charge, it is better to use same charge. Suppose more positive charge here and less positive charge here. So, in that case, positive charge will start moving from this to this side, means electron will start moving from this to this side. So, they will balance each other. Suppose 3 coulomb, 3 coulomb. Initially, it was suppose 7 coulomb and it was 1 coulomb. So, now if you connect with this wire, then it will become 3 and 3, 6. Okay, sorry. So, it is a 5 coulomb and 1 coulomb. So, if you connect this wire, then it means total charge will be same, but they will arrange in such a way that current charge will start flowing from one place to another. This happened because of the conduction. So, conduction at one place there should be more charge, another place less charge. Then in that case potential difference will be there, that is why current will flow through it. So, this is called conduction. So, three ways to produce the charge. Okay. So, okay, this we have discussed, and now few more properties, because I am coming to that point, because one numerical is there in your book which is related to the properties of charge. So, first property, same charge or like charge repel each other, right? Like charge repel and unlike charge attract each other. This you already know, right? Like charge repel each other and unlike charge attract each other. One property. Second property, we call it quantization of charge. This is there in your book, but they have not mentioned it, but for one question they have given. Quantization means any charge on any body is integral multiple of the basic charge. So, what is basic charge? Generally any charge, suppose you charge take q. Q is always integral, n is integral multiple of basic charge. This electron, suppose charge on electron is considered as the most basic, below that is not possible. So, this is unit charge, means charge on electron. Well, how much charge is there in electron?
0.6 into 10 to the power minus 19.
Minus 19 coulomb. So, this is called unit charge, means basic charge. So, any charge you take, suppose 5 coulomb charge you take. So, that these 5 coulomb charges are made up of these electrons, means n number of electrons, and this n is nothing but integer. It will never be fraction. Integer means you understand. So, integer, it will never be fraction. So, now suppose one example, I think one question is there in your book. Suppose you have 5 coulomb charge, negative charge. So, how many electrons are there present in that 5 coulomb? That you have to find. So, from this formula you can find. So, at the Q you can write 5, N we have to find, E we have this formula, this value of E is how much? 1.6 into 10 to the power minus 19. So, now you can find the value of N. N is how much? 5 by 1.6 into 10 to the power minus 19. So, how much we will get? Around how much? 3 into 10 to the power, around 3, means it is not exact. So, around 3.1 or something, 3.1 into 10 to the power 19 electrons are present there. So, number of electrons in 5 coulomb charge is how many? 3.1 into 10 to the power 19 electrons. It is a very large number. So, this is called quantization of charge. So, this is the first formula in your book. I just forgot to mention this. So this is related to the property of charge. Means what is property of charge? Any charge is the integral multiple of the basic charge, and this property is called quantization of charge. Okay, quantization of charge. 1, 2, 3 more properties are there, like quantization we discuss, quantization, and then we have additive property. These are simple. Quantization is important. So quantization, from quantization they may give the question Q equal to NE. Second thing, second property we have is additive property. Means we can add the charge just like in algebra we add the charge. Additive property. Additive means suppose you have plus 5 and you want to add minus 13 coulomb. So you add simply just like algebra. How much it will come? So this is plus 5.
Minus 8.
5. Yes, very good. So plus and minus will become minus 13. So 5 minus 18 means minus 8 coulomb. So just like algebra, that's why we call it additive property. Just like algebra, you can add here also the charges, plus and minus. So this is quantization, additive property, and one more property is there which is sometime used. This will help you in future also. So we call it conservation of charge. Just like energy is conserved, charge is also conserved. It can only be produced, it can only transfer from one object to another. Just like energy, what is conservation of energy? Energy can neither be created nor be destroyed, only transfer from one form to another form. Same definition you can write here. Charge can neither be created nor be destroyed, only it transfer from one body to another body. It will transfer, then a charge will be developed. So but total charge of this universe is constant. Okay, so that's why we call it conservation of charge. So charge is also conserved, only transfer of charge is possible. Sometimes there are some exceptions, suppose not exception, but actually, so you may say that neutron can also be divided into protons and electrons. So here also same charge, but they will cancel the effect of each other. It means the net charge is always constant. Net charge of this net charge of an isolated system is always isolated system. Our universe is, you can consider as isolated system. So the net charge of universe is constant. Okay, so like this you can define this. There are many ways to define this. Okay, so this three properties, sometimes this is important because this one question is there in your book. So that's why. Otherwise, these two are general thing which you have to keep in mind while solving the numericals. Okay, done. So this was about charge, and current I think we discussed. Current is rate of flow of charge is called current. So this was about charge. Electric current. Electric current, now you understand, only electrons are possible inside the wire. Electrons will start flowing with the help of that electric field. In case of electrolyte, means ions can be positive as well as negative ions can move, and they will contribute in the electric current. Here only electron will contribute in case of wire. So electric current is done. So till now we have got three formula. First, quantization, N E equal to Ne. Second, I equal to Q by T.
V by R.
And potential also we have discussed. V equal to Q, W by Q. So three formula we have discussed. Now there is relation between V and I. Okay, there is relation between, that relation is called Ohm's law. Ohm's law is nothing but the relation between V and I. So V is directly proportional to I. Directly you can write potential, and what is the definition of this Ohm's law? The potential difference between 2 points in a circuit is directly proportional to the current flowing through it. Suppose you take one circuit. Circuit, I think all of you know this. Circuit, for circuit there are four essential parts. First, battery should be there like this. Then wire should be there, and one bulb or any resistance, and one switch. Okay, switch you can represent like this as well as this. So if you place one point here, it will be closed. Suppose here this is closed. So switch, battery, wire and bulb. At least these 4 components are essential to show the circuit. And without circuit, if circuit is closed, then only a current can flow through it. And this circuit is called, the definition of this circuit is closed and continuous. So it's a closed and continuous path. Closed, then only we call it circuit. It should be closed because just now suppose it is open, then current will not flow through it. It should be closed and continuous. So that's then only current can pass through it. Okay, so that is circuit. And in 4 component. Apart from this, we have many things. And symbol is given in your books. Suppose rheostat. Rheostat, you know. Rheostat is just like resistance, but it's a variable resistance. So we represent like this, or another way to represent is like this. Okay. So the rheostat means variable resistance. Resistance we represent like this. Bulb we represent like this. Battery means number of cells, 2, 3 cells you combine, it will become battery. This is switch. What else? Voltmeter and ammeter. Ammeter just like this, positive and negative. Voltmeter V, like this. So these are voltmeter, ammeter. Ammeter to represent to measure the current, and voltmeter to measure the potential difference between 2 points. Suppose you want to measure the difference between these 2 points, potential difference between this bulb. So A and B. So you will just attach voltmeter here in parallel. This is called, if you are attaching some device without breaking it, then it will be always in parallel. So it's a parallel combination. Voltmeter is always attached parallel, because we need to find the potential difference between those two. In case of ammeter, we have to break this and we have to attach ammeter here. So it's in series. This ammeter is in series, voltmeter is in parallel combination.
Excuse me, sir.
Just ask
Sir,
me.
in Ohm's law,
Yes.
sir, if V is proportional to I, then V is also inversely proportional to 1 by R, no, sir?
V is proportional to I, so V equal to Ri we can. If you remove this proportionality sign, you have to place one resistance, constant. You have to place some constant, then only you can write I. So V equal to Ri. So yes, I equal to V by R. So it means I is inversely proportional to resistance.
Yes.
So I means current flowing through this circuit is directly proportional to voltage. Means if you increase the value of this potential difference, then current will also increase. Suppose you take 3 volt, then you take 6 volt, then you take 9 volt. In 9 volt, more current will pass through. 3 volt, less current. So directly proportional to V. And second, resistance. If you increase the resistance, suppose this bulb is a kind of resistance. If you increase the value of this resistance, then less current will pass through it. So it's inversely proportional to resistance and directly proportional to voltage. Okay. So generally, the definition for Ohm's law is like this: the potential difference here, the potential difference between, suppose potential difference between any 2 points in a circuit. Suppose you can take these 2 points also, A and B, no problem. You can take these 2 points also, A and B, anywhere. So potential difference between 2 points in a circuit is directly proportional to the current flowing through it. This is the definition of Ohm's law. From this formula you can define it. Potential difference is directly proportional to the current flowing through the circuit. So these 3 components we have to define in the definition. Potential difference is directly proportional to the current flowing through it. So 3 parts of this definition. This is Ohm's law. And mathematical representation is like this, and you convert this, you remove this proportionality sign and you make it equal sign. Then one constant will come, and this constant is called resistance. So new term we got, resistance. Till now you are understanding, or it's good? Because I think one time you have done, right? So that's why I have explained all this in short. Any doubt?
No, sir.
No,
Okay,
sir.
good. Now we have done electric current, electric circuit, and Ohm's law. After this, we have combination of resistance. Okay, combination of resistance. So combination of resistance, that is little, because most of the numerical will come from there. So combination of resistance, two type of combination we have, because resistance, one more thing, resistance, two formula we have for resistance. First, from Ohm's law we got one formula. What is that? From Ohm's law, R equal to
V by I.
V by I. Very good. So now one formula we have, but this formula we cannot apply in all situations. Suppose you are given a wire, suppose one wire of 2 meter length, and it's made up of copper, and thickness is suppose 5 centimeter square, means cross sectional area. These three things are given. In that case, you have to find the resistance of this wire. Then you cannot apply this formula. This formula is applied only in one situation, when resistance is attached in a circuit. Suppose here circuit is given, and it is one resistance is attached here, and current is flowing through it. Current, suppose I is current, and here V. Then we can find the R. So in case of circuit only, we can apply this formula. Not, suppose you are given a wire, because resistance is everywhere. Whatever you take, there is resistance. High or low, it depends upon the material. Suppose you take silver wire, then less resistance. If you take iron rod, then it will be more resistance. But we have to find the resistance of this wire also, piece of wire. In that case, we have another formula, R equal to, because R L by A. This is the formula. Because one definition is R is directly proportional to length and inversely proportional to the cross sectional area. If you combine these two, then R is directly proportional to L by A. Now you remove this proportionality sign, so you have to place one constant. Here constant is rho, L by A. So this is how we get this formula. This depend upon the material. Rho, this is rho, and this is called resistivity constant, and this is fixed, this is constant for any particular material. So suppose for iron it's constant, for copper it's constant. There will be table given, so they'll always give, suppose copper, so they'll give the value of this resistivity constant. So resistivity constant of copper is something that you have to refer in table is given in your book. So resistivity constant will be given, this constant. Then, and resistance depend upon the length also, it's directly proportional to length. If you increase the length of this wire, resistance will increase, but if you increase the thickness of wire, then resistance will decrease, because it's inversely proportional. Generally what happens, suppose very thin wire is there, another very thick wire is there. So generally we have this perception, if there is thick wire, then resistance in this case should be greater than this. But no, resistance of this is greater than this. So if you increase the thickness, resistance will decrease, not increase. So this formula help us to find the resistance of a wire, piece of wire, which is not there in the circuit. So without circuit also we can find the resistance. For that we have this formula. So two formula we have, one in circuit, second without circuit. Based on this also we have some I think Pragya, are you there? She is there or not? Okay. So one very general numerical. So suppose one wire you have, she asked me this question. So this wire, suppose this wire is 2 meter of length, okay, and thickness is something, anything you can take, suppose 5 centimeter square, or not 5, 10 centimeter square. Now what will happen, if you start stretching it from both sides, then this wire will become thin and the length will increase. Suppose length became double of the so length became 4 meter. Okay, and initially resistance was R. We don't know how much it is, but initially it is R for this piece of wire, which is, the length of this wire is 2 meter and thickness is 10 centimeter, and it is made up of suppose iron. So now with the help of that table we can find the resistance R equal to rho L by A. Okay, rho L by A. With the help of this formula we can find the resistance of this wire. But in second situation, you are stretching this wire and length is increased by 2 times. Suppose it was initial 2 meter, now it became 4 meter. Now nothing is given. Now you have to find, suppose resistance is 10 ohm. Now what will be the resistance of this wire if you stretch it? Then from this formula you have to find.
Sir, I have a doubt, sir.
Haan.
Sir, when they increase the length of the wire, won't the cross section reduce by the same
Yes,
time?
yes. It's directly proportional. If you increase the length double, the thickness will be half. So they are proportional to each other because mass is constant now.
Sir, 40 ohms. Sir, is it 40 ohms?
4 times. What you said?
Sir, is it 40 ohms? So like it is like
Yes,
increasing
40
by 4
ohms.
times.
40 ohm, correct. 4 times it will increase. We got two length double. So suppose in first case this is the resistance. In second case we will write the same thing. Rho will not change because material is still iron. Initially it was iron, now still iron. So rho will not change. Length became double. So 2L we will write. Thickness became half. So A by 2. So now new resistance R equal to, we can write rho, 2 will go up, this 2 will go up, so it will become
4L.
L by A. So now the new resistance is nothing but 4 rho L by A, and L by A is given. This rho L by A we have given 10 ohm. So we can put here R dash equal to 4 into 10. So 10 4 times. So 40 is the 40 ohm resistance is the answer, like this. Okay. So this is general question. Very often they ask this question. Reverse is also possible. Another question, similar question I will give. Suppose very thin wire is there like this. Now you fold it 1, 2, 3, 4 times. Suppose you fold it. Okay, one wire is given. Suppose this much length. Now you fold it 4 times. So one. Suppose one here and one here. 3 times. Okay, it's 3 times. So initially the length was, suppose now first if you fold it, then this will become like this, 1, 2, 3. Okay. So this is the length now. So only this much length is left. These are 3-fold. So initially resistance is, suppose R equal to 2 ohm. What will be the resistance in this case? Not 2, 12 ohm suppose. 12 ohm. So initially 12 ohm. Now what will be, this is the first situation when length of wire is given L and thickness of is A. Now what will be the resistance? Here R is given 12 ohm, length. So give some length.
Sir, L by 3 by 3A. L by 3 by 3A.
L by 3, yes. So in here
by 4A. Divided by 4A. So 3A.
3A. So 3 times. So if you fold it 3 times, then this thickness will become 3A because 3 thickness are there. Okay. So this 3, if you fold 3 times, so thickness will be 3A and length will become L by 3. So new resistance will be like this. Rho will be same. So L by 3 divided by 3A. So it
4
will,
ohms.
no, 3 3s are 9 ohm. So rho L by A into 1 by 9. 3 will come down now, 3 3 9. So new resistance will become old resistance. This is old resistance which is given 12. So 12 by 9 will be the new resistance. Okay, like this. So initially you write, first you write the resistance in first situation is like L by A. In second situation the resistance is like this. So you apply the same formula and you can find the new resistance. Okay, so one based on this formula means resistance of a piece of wire you have to find. They can give this type of question. Either they fold it or they will stretch it. Only two possibilities. Okay, so related to resistance this. Next we have related to combination of resistance. So we have to apply Ohm's law now. Combination of resistance. So combination of resistance, two type of resistance, two type of
Series
combinations, parallel and series. So in case of parallel, what is the formula? 1 by R
1 by R is equal to
1 by R1 plus 1 by R2
1 by R2.
plus 1 by R3 like this. It will go till how many resistance are there. And in case of series, it's very simple. Directly you can write.
R1 plus R2 plus R3.
Directly you can write R equal to R1 plus R2 plus R3. So now here two type of questions possible. First they will ask the derive this formula, derive the parallel combination formula, or they can ask series combination formula, derivation. So derivation, suppose in derivation first you have to draw the diagram. Suppose you in case of parallel combination, so three resistance you draw like this and them parallel to each other. So these are parallel to each other. Connect them with a battery. Suppose value of this battery is V and this is R1, R2, R3. 1 marks will be given for this, for diagram. Now you write, because it's a parallel combination, in case of parallel combination voltage is same for all these three resistance. So V is same for all these three resistance, same volt V, but current will be different. Suppose here current is flowing I, this current will be divided into three parts. So suppose this is I1, this is I2 and this one is I3, because here junction, this is one rule. So just like water, suppose flow of water, same thing happens with the flow of charge also. Suppose there is way in here at the junction, water is flowing from this side, it's coming, then water will go this way and this way also, right? It will be divided into three parts. Same thing happens here, current is flowing like this and now that current will be divided into three parts. This current was like this and now it will divide into three parts because they got junction here. We call it junction rule. So here at the junction, this current I will be divided into three parts. But these three, if you combine these three, it will be equal to this, because just like water, it can never be more or less than this. Okay. So I equal to I1 plus I equal to means current, total current equal to I1 plus I2 plus I3. So first you write this I plus I1 plus I2 3, because in case of parallel combination this is possible. Current will be voltage will be same for all this and current will be divided. Now apply Ohm's law. Applying Ohm's law, so V by R equivalent, because this is Ohm's law, V by R equal to I. So I equivalent we can write like this, equal to I1. I1 equal to how much? This is I1. So I and V is given. R is given.
V by R1.
So V by R. So V is same. So I1 at the place of I1 we can write V by R1. At the place of I2 we can write V by R2.
R2.
And similarly V by R3. Because V is constant in all these three, resistance is different. So current is different. So first you write this and second from Ohm's law this, and then you remove this voltage from both sides.
Common making.
Then we will get this formula. Okay, 1 by R equal to 1 by R1 plus R2. So 3 step. So derivation also they may ask. So first 1 marks for this, 1 marks for this, and maybe 2 marks or sometimes 3 mark also. So you have to apply Ohm's law for here. So voltage is same, and 1 mark for this they will give same, and I equal to I1 plus I2 junction rule. And then third, apply Ohm's law and you will get the formula. So maybe 3 mark question also they may ask, the derivation. Okay, so diagram is also important here. So this is parallel combination. Similarly, we have series combination. So again we have to apply, in case of series combination also we have to apply Ohm's law. So Ohm's law again will apply. So but first diagram. So diagram is simple. Means series means what? Head to tail. And in case of parallel, always head and tails are together. So suppose this is head and this is tail. So all head and tails are together. Here heads and tail are different. So head will attach with the tail of another. So this is the definition of series combination. So this is head, this is tail. This is head, this is tail. Like the head and tails are combined. Here head and heads are combined, tail and tails are combined both sides. So this is parallel, this is series. Now again connect this with a battery which have some voltage, suppose V voltage. In this case current is same because it's not there is no junction. So current will not divide. So current is same for all resistance. Current I is same for all resistance. First you write this, but voltage is different. This is V1, this is V2, this is V3. Because I is same but resistance are different. So in that case I into R equal to resistance. So now we can write like this, V equal to R, because this V potential difference is always equal to this V. This much potential difference has been produced by battery, and that is divided into 3 parts. So V equal to V1 plus V2 plus V3. Similarly, just like I equal to I1, I2, I3, same thing here. So 1 marks here, 1 marks here. Now apply Ohm's law. So V equal to I into R. So R equal equivalent. V1 equal to I into R1, I R1 plus I R2. I is same for all. So I R3. I cancel from both sides. You are left with this formula. Okay. R equal to R1 plus R2 plus R3. So like this. So this is the derivation. Okay. So this much is there in resistance. Now based on this, they may give many new type of numericals. N number of numericals is possible. Okay. So till now you understood this.
Yes, sir.
Yes, sir.
Now you ask me question, your doubts, because I'll stop here. Enough theory part we have done. So theory part till combination of resistance, I think the heating effect and power is left only. Rest all we just discussed. So now you ask me your doubt. Clear your doubt, then we'll stop.
Do you want to send us the question in the text form, or can we just read out the question?
Yes, you can read out.
A current of 1 ampere is drawn by a filament
Okay.
of an electric bulb. Number of electrons passing through a cross section of the filament in 16 seconds would be roughly.
Okay. So T is given 16 seconds and
Yes, sir.
current is given 1 ampere. So directly you can apply formula Q equal to I into T, because I equal to Q by T. This we have done, right? So directly you can apply 1 ampere into 16 seconds, where both are SI unit. So no problem. 16 coulomb charge will pass through the filament.
Sir, the options they have given is 10 to the power 20, 10 to the power
Electrons
16.
they are asking, I think.
Yes, sir.
Okay. So this is charge. Now you have to convert this into electrons. So again you apply the conservation of quantization of charge. So N Q equal to Ne. So Q is how much? 16 coulomb, and N we have to find, and E is 1.6 into 10 to the power 90 coulomb. So now n equal to, Coulomb will cancel, so n equal to 16 by 1.6. Okay, 16 by 1.6 into 10 to the power minus 19. So this 19 will go up, and if you cut this, it will become 10. So 19 and plus 1, 20. So n equal to 10 to the power 20 electrons. Is there any options like this?
Yes, sir, it is there.
So this is the answer. So two things you have
Thank
to
you, sir.
apply: Q equal to IT, and second Q equal to NE. Quantization and current. Two formula. Okay. Anything else? Rajat?
Yes, sir.
Any doubt? Even in book,
Sir, one doubt.
wait 1 minute. Even if you want book, 1 minute. Charge it. So from book also you have that. I have book. Wait 1 minute. I'll show it. Have you gone through all the questions like blue color and exercise?
Yes, sir.
Any doubt anywhere? I'll show you the book. Wait 1 minute.
Sir, one doubt from the electric potential, sir.
Ask me.
Sir, you said battery, right? Sir, it had like stored potential in one terminal which travels to the another, right, sir?
Tell me again what you said.
Sir, like one terminal of the battery has extra charges stored which travel to the
More
another.
charges than another. Then only flow of charge is possible.
So then when the battery gets old or used up, so then the stored up particles get already travel to the another terminal, sir.
Slowly all the stored particle will start moving towards each other. They'll cancel the effect of each other, because if you combine electron and proton, positive and negative charge, they will annihilate, means the charge will vanish. So slowly that battery will die, means potential difference will be 0 at last. And they have made the battery in such a way that the same amount of current is flowing through this. So it means charge will flow slowly, means that's why it takes some days. Suppose you are using the cell, it will take suppose 1 month. Within 1 month it will maintain the same potential difference, means same amount of charge is passing through from one terminal to another while using the battery. So slowly all the charge will be used up. Then if all the charges are used up, then we call it battery is dead. And that charge is from where we get? From chemical. Few chemicals are used inside the cell which produce this difference, different of charge. Just like in electrolysis also, you can just imagine. In electrolysis also, charges are moving. Here electrons will move. Okay.
Yes, sir.
Even in battery, suppose you take this solar battery. So what they use? Generally from solar energy we get the electrical energy, and that electrical energy will be converted into chemical energy, which is just stored in the battery. That battery we can use for later time. It's like nowadays we have solar, not solar, means electric scooter. Electric scooter is very common now in Bangalore. You can see everywhere. So now what they are running on battery. So that battery is charged through electricity. Sometime that battery can be charged through in later, means suppose in future that battery will be charged through this solar energy also, and the efficiency of that will increase with the time, with the development of technology. So I think in future energy will be free because sun is free, sunlight is free. So that's why this technological development will help us. So that will means any kind of energy, electrical or solar energy, will be converted into chemical energy. It will divide the charge inside, and slowly they will be use that energy, potential energy, stored energy actually. Okay, that's why potential difference we call it. Similar term. Okay.
Yes.
Okay. Anything else? Circuit, define the current, unit current. Current ampere we have just defined. If 1 coulomb charge will pass through the cross section of a wire in 1 second, then we call it 1 ampere. Okay. Define unit of, because sometimes they'll ask the unit to define the unit also. So 1 ampere is the unit of current. So 1 ampere is nothing but 1 coulomb by 1 second. So if 1 coulomb charge is passing through a cross section in 1 second, then that current is called 1 ampere. So from formula also you can define. Okay. Calculate the number. I told you na, this is not given, quantization formula is not given in the book, but they have given this question. So it's possible in a board exam they can give. Number of electrons 1 coulomb you have to find. Okay. Electric potential, potential difference, that definition is also not given, but I'll send you one PDF. In that it will be defined. So just mug up, means just by heart it, because just like same in both case, almost similar definition. It's work done. In one case, in case of potential, there will be 1 point, and potential, electric potential is nothing but the work done in bringing a unit charge. Unit charge means we have to divide by charge, in bringing a unit charge from infinity to a particular point P. And in case of potential difference, we have to write like this. So here work done in bringing a unit charge from point A to B. So divided by Q. In general they have given this formula, but in 12th grade you will get these two formula. This is about potential, this is about potential difference, but they have given both point here, electric potential and potential difference. So that's why you should have this concept. So directly you just by heart those two definition, either if they'll ask, just write it and write this formula. Based on this formula, one numerical possible. Work done per unit charge. Voltage also same thing, with the help of formula also you can define the voltage. 1 joule 1 coulomb.
Sir, for heat also we use the joule as the SI unit, no, sir?
Any kind of
Heat
energy and work, the unit is same, joule. Heat, light, any kind of energy, the unit is SI unit is joule. Some another units are also like calorie. In case of food, generally how many calories are there inside the food. So the calorie is also one unit, but this is not SI unit. SI unit is joule, and joule we can define with the help of this also formula. So for work done we have formula force into displacement, and this work we can assume as energy. So energy is nothing but F into D. So Newton meter is also another name for joule. Newton meter. Okay. Circuit diagram, I think it's easy. Ohm's law we have just discussed. One practical based question they may ask, you have to prove Ohm's law. So means if you increase the value of voltage, current will also increase. Means V by I is always constant. So V is directly proportional to I. It means V equal to R by I. If you remove this proportionality, so V by R is always constant. Sorry, V by I is always constant. So V by I, you have to find the the fraction of V by I proportion, and this is always constant. Means in each case the value will come same. So if you take suppose 1 ampere, here you take 2 ampere, 3 ampere. So similarly here it will become suppose 2 volt, then it will become 4 volt, it will become 6 volt, like this. If you take the fraction, it will be same in all cases, 1 by 2, 1 by 2, 1 by 2. So this is one numeric practical which is related to this chapter. You have to verify Ohm's law. Generally Ohm's law is not followed 100% because there is some error. So not error means Ohm's law only in very ideal situation Ohm's law is followed. Means this graph you will never get straight. There will be some variation. This graph, it will
So
never be.
because the temperature and all will
Yes,
always
so
not be
many
constant.
things will come into consideration. Temperature will increase. Yes, because of the resistance, temperature will start increasing, and with the temperature, resistance will increase. So that's why this value will not be constant. And first temperature, few more things are also there. Suppose you take diode, in that case suddenly the resistance will decrease with increase. So many things are there, but that's why Ohm's law is means strictly it will never be followed. Only in certain situation, when in ideal situation only it is followed. Okay,
Sir, brightness of the bulb, is it decided by the current or what factors? The brightness of the bulb.
Brightness of the bulb. Suppose you take nowadays we have LED bulb. LED I'm saying, LED bulb. So now LED. Suppose you take 9 watt bulb and you take 20 watt bulb. The brightness of this 20 watt bulb will be more than this. So it depends upon the power of this bulb. Power is directly related to the intensity of the light which is produced. So power means what? Power is nothing but work done per unit time or energy consumed per unit time. So how much electrical energy this bulb is consuming in 1 second, that will decide the power of this bulb. If more energy is consumed, then more power it will have and more energy it will radiate. So the brightness of the bulb depends upon the power, and power of this bulb depends upon the means for power what formula we have. For power, three formula we have: V into I, V square by R, and I square R. So generally, if you take heating effect, H is equal to I square RT. So heating, because heat will convert into light energy here. So heat depends upon current which is flowing through it, and resistance of this bulb, and time. For how many seconds, for how many minutes this current is flowing, going through this. So heat depends upon these three things, and if you divide by time, then you will get power. So power depends upon current as well as resistance of this bulb.
Yes, sir.
Okay, and directly means more power, more brightness. Also you can say.
Sir,
Yes.
are resistance and heat directly proportional?
Resistance and heat is directly proportional to resistance. So more, if more resistance are there, more heat will be produced. So Joule's law of heating says that heat is directly proportional to I square, directly proportional to R, and directly proportional to T. If you combine all these three, then it will become I square RT. Here one constant will come, but that value of that constant is 1. So this is the formula for heating effect. So heat will depend more on current because it's power 2, here power 1, these two. So it will more depend.
What is that constant?
What?
Sir, you told constant value is 1.
Because if you combine all these three, the formula will be like this: I square RT. Now you have to convert this proportionality into equal sign. Then we have to place some constant IRT. In this case, experimentally we get the value of K as 1. If you take unit value of all these three, then suppose 1 joule we got this side. So if you take here 1 ampere, and here you take 1 ohm, here you take 1 second, then value of this K will be 1. Sometimes these are not same, sometimes these are different, but most of because it depends upon the experiment, means material. So experimentally it is verified that value of K is 1. So that's why the formula we have Generally, Joule's law of heating is explained like this: heat is directly proportional to square of the current, resistance, and time, directly proportional. So if you add all these three, this will come, and if you convert this into proportional, because one constant should come, but in most of the cases this constant is 1. So that's why we formula for H is I square RT. We don't, just like in that case Ohm's law, V is equal to I. This we cannot write. K value is not here. Here we have taken R. That constant is R, and this value depends upon the material. Similar thing here, but here value of K is 1. Here value of R is something. So it depends upon the experimental value. So mathematical modeling we call it in physics. So during that, sometime we have to take the help of experiments.
Yes, sir.
Okay. Here also look. Here also we have got one resistance, resistivity. Here constant is resistivity. Here also 1 is not the constant. So whenever you change this proportionality sign into equality sign, you have to place one constant. Sometime that constant will be 1, but most of the time it will not be 1. So if it is not 1, then we have to place that value. Okay, so I think these are the resistivity constant given for all this. Silver is the minimum, 1.6 into power minus 8, and maximum for paper, dry paper, 10 to the power 12. No, I think beyond that also we have ebonite rod. So many things. So insulator will have high resistivity constant, metals will have low. So
Sir, in the superconductors, does it have negligible resistance value or no resistance, sir?
superconductor, generally we call it superconductor because there is almost zero resistance, so there is no wastage of energy. That's why superconductor have, but in real life it's not possible. I think at very low temperature we get the superconductivity of any material. So superconductivity means there is almost zero. Zero is not possible in any case, but almost zero, tends to 0.
Yes, sir.
In certain situation this happens. In certain situation, like if you keep decreasing the value of means temperature of the any material, then it will become superconductor.
Sir, but after a long time, even those superconductors may become hot.
Even superconductors,
They can become hot after a long time.
that's why I'm saying it's a ideal situation. In ideal situation only it is possible. Just like resistance, we cannot avoid resistance. There will be resistance in everything. If there is matter, there will be resistance. So because electron has to flow, and the electron will pass through some lattice, so there will be some disturbances. That disturbances is called resistance. Means free flow is not possible. So 100% zero means zero resistance is not possible, but tends to 0 is possible. Means almost will decrease. Okay. Heating effect also, and then practical application of this. These are means theory part. This electric power is important. Next class I do this electric power, and then we'll do
Sir,
some.
heat will be in which more, sir, like in the series or the parallel, sir?
In which case there will be more heat.
Yes, sir.
Yes. Means what is your question? Suppose 2 resistance you have. If you combine them in series R1 and R2, then resistance will increase.
Sir, in which case it will be more, sir? When they are connected in series or when they are connected in parallel?
And what about the potential? Potential is same in both cases.
Yes, sir.
Means
Suppose.
potential is same in both cases. So here suppose voltage is same R1 and R2. This is your question, right? In which case there will be more heat.
More
So if you
heat.
combine them, resistance of this will be more, voltage is same. Here resistance will be less because it's a parallel combination. In parallel combination, resistance is always less than
Yes, yes.
1. So, and in series always greater than the greatest one. So, and this is less than the least one in case of parallel. So, the resistance is less here, voltage is same, formula we have V square by R. Here we have V square by R. Because for power, for raise, okay, I square RT, because we have the formula I square RT for heating effect I square RT. But here you see current is not same for both. So here current is same for both resistance. Here current is different. Two different currents will pass through this and this. So, and if you combine them, this current will also change. So that's why in this case, if you combine like this, then better you apply this formula V square by R, because voltage is constant for the both resistance. Current is different in both. So in which case resistance is less. So here resistance is more, here resistance is less. So more resistance, less power. Time also we have taken time. So this, in this case less power means less heat, and here more power. Wait. So V square by R. R is more here, so power is less. Power is less, and time is same. For same time, for same time, how much heat will be developed there. So if you take the numerical value, I think for in this case the power is less, so more heat will be developed here. Why? Because heat is directly proportional to R, its current. Here resistance is more, here resistance is less. But current will also differ. Here current is not same in both cases. If you have taken voltage same, then current will be different. Here current will be less, and here current will be more. And heat depends more on the current and less on the resistance, because it's a square of the current. So that's why more heat will be developed in this second situation than first situation. If you consider only resistance, in that case you tends to write this in this case more heat will be developed because resistance is more. But no, we have to consider current also, and heat depends more on current, less, because power, double power means power 2 is there, no? So that's it. Okay. So just reverse. Sometime tricky, maybe tricky. With the help of numerical value also you can verify. Okay, got it, Dhruti?
Yes.
Okay, so I think it's almost 5 o'clock. Okay then, so I hope you got something. So next class, I think this is, after this only 10% will be left in your syllabus, that magnetic effect. So in this month you can
Yes, sir.
go through all the questions, come with your doubts and questions. You can share it also here in WhatsApp. If you will send, I'll get this. Web WhatsApp is there, no? So from there I'll get the questions. So you can send directly to this also.
Yes, sir.
So we'll discuss this here. So come with the questions next time. Okay. So I think theory part I have tried
Yes,
to
sir.
clear it. Okay. So numericals, I think more numerical is left. You more practice, more than because in light chapter you already have some idea. In electricity, first time you are getting these many numericals. So go slowly, but go to other sources also, not only this NCERT. Try to solve some more questions from different sources.
Yes, sir.
NCERT, next time we will do this. Okay. If you have any doubt, come with this. Okay, so we'll end this session today. Okay, thank you all. And in between, if you have any doubt, you can send me WhatsApp. If possible, I'll rectify there. Okay.
Yes, sir. Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Okay, bye.